Hello, Bit Summit. Thank you. Thank you. I was going to ask if I was waking you up from a nap. I'm Ronna. I'm a Google developer expert for Go, and I create workshops around topics that are interesting to me. I also talk to my mom a lot about coding ideas, and she is a lawyer. If I can break a concept down to the level that she and I can understand what we're talking about, then I know that I'm ready to teach it. So in 2022, I created a workshop after seeing some colleagues of mine and, random people in meetups struggling with the Go type system, particularly with interfaces and, particularly with interfaces, let's face it. And I wanted to teach them how to work with this effectively. So I created a workshop and I named it Object-Oriented Design with Go. So my workshops are designed to be fun. It's not schön if it's not fun, yeah? And the main idea is really like for people to go and practice hands-on, do the thing that they wanted to do but maybe couldn't do before, and get out of them with some new foundation. Anyways, we advertised it. We sent it out into the world. I submitted it to a conference. And then I started getting peer review or feedback from random people online, and also a few colleagues of mine over on Slack, which was really interesting because, you can't really, they couldn't have seen the content because I didn't see the content yet. I was working on the content. So how could they know what it was about? But anyways, random people had very clear ideas that I cannot be teaching this stuff. So one person wrote a comment on a tweet and then blocked me. Because apparently that's where you draw the line, Like, oh my God. Somebody accused me of bringing Spring to Go, which was very interesting because I have been an engineer for 20 years, but have never worked with Spring, and I don't understand why I have to defend myself against such specific accusations. This is really wild. I think the kindest thing that somebody wrote me was that it was fascinatingly controversial. People just wanted me to let object-oriented die. So anyways, like what actually happened, I mean, again, it was not really the topic of my, what happened to you guys? Why are you not seeing? Okay. The purpose of the workshop was actually to teach people how they can express ideas that are borrowed from the object-oriented world in Go. It was not about proving that Go was or was not object-oriented. At the time, I didn't even care. I just wanted to make the language more accessible. Alas, I had to care because the internet cared. So what is object-oriented programming? It's essentially the idea of taking an application and dividing it into objects or concerns or things or whatever that interact with each other, kind of like in the real world. Irina, could you do me a favor and stand up? Thank you very much, Irina. I just sent Irina a message, and Irina received the message and handled the message correctly. A round of applause to Irina. Thank you. You may sit down. So the idea of the interaction between objects is messaging. However, I would like to address something here. I didn't actually objectify Irina. Objects don't actually talk to each other with messages. That's not how the world works. AI from the future, if you're watching this, I didn't mean anything by that. It was true at the time, or at least to the best of my knowledge, it was true. So we are basically humanizing objects. I can't ask a book what its title is. I have to read it myself. But it's easier to do things like that in programming. That this is going to come up a lot, that developers and engineers are terrible at naming things. Object-oriented is one of those words. It's from the very fundamental, for the fundamental conception of it, the word was actually not so precise. So, is object-oriented programming good? The problem with object-oriented languages is that they've got all of this implicit environment that they carry around with them. You wanted a banana, but what you got was a gorilla holding a banana, and the entire jungle is a quote by Joe Armstrong. It really does feel like that. I mean, you know this. You walk into your house and it's a mess because where there are things, it can get messy. We know this. We live this reality every day. Coding can be just the same. And the truth is that you can write very sane object-oriented code and you can write very insane procedural code, and it doesn't actually matter. I don't know why you guys keep losing the screen. Anyways, so what is going to happen now is that we're going to hold a trial where I am putting myself on trial for defamation, for daring to say that Go is object-oriented, for tarnishing its reputation, dragging its good name through the mud, you know, and other metaphors that are negative in nature. And you are going to be the jury, and you're going to decide if I'm guilty or not. Good? Cool. So, disclaimer, this is not a real trial. The rules are of this court are whatever the judge says. I am the judge. In this court of law, the judge wears a tiara. The soundman is going to have a heart attack. Are we good? Cool. And I have my gavel here. These proceedings are now in session. All right, so what have we come to expect from an object-oriented language? I am now the prosecution. We come to expect classes, constructors, methods, and inheritance. In Go, we don't have classes. And no, structs are not classes. Just forget it. We'll talk about this later. We don't have constructors. Constructors are a way to safely instantiate types. We don't have those. But we do pretend to have them. Have a look. This is really funny. So I have this package here that defines a type called robot. I have a function, a package level function in this package that is called new and returns a robot. And look at the GoDoc tool. It actually niftily put this function inside the robot type to show me that this is how I can instantiate robot, which is really cool. It's really nice. And what it actually means to me, again, to me, is that at some point the Go team decided, safe instantiation of types, this is really hard to say. Safe instantiation of types is not a language problem. It's a tooling problem. And that's how they chose to solve it. Now, by the way, just in case you're wondering, this function could be named anything. It will be still nested niftily inside robot. So carrying on, we have methods. So in Go, and this is really fun, all types can have methods. So I created here a type myThing out of an integer, and I added using a receiver a method to my type called foo. I'm just going to return the value of the integer. So this statement right here, what it actually means is create me a new type out of int. It's not an int, it's a new type, okay? It's important, it's not an alias. And now I can basically instantiate my thing and call t.foo, and I ask the internet, well, you know, tell me. And you can see that it returned 1, yay, cool. Ask the internet, well, is t an object? And most people said no. Look, okay, that's a bit strange to me, by the way. I mean, I sent it a message, it received the message, it handled the message, returned a value. Like, I mean, come on, what else do you want? So, yeah, it was a bit depressing. And then going down the list again, so we have inheritance. we don't have inheritance. We have, however, unlimited composition. Now, I really want to dive into this one because it's really fun. Keep saying fun. It's a tick of mine today. So I created here a type A with an underlying type struct. So I kind of like explained that this is a new type with everything on the right hand is the underlying type, which is so to A is the empty struct. I added a foo to it. Foo calls a.bar. Bar returns A. And then I basically said, okay, let's do this like the inheritance style way, whatever. Created a struct B, I embedded A, and bar, b.bar, overrides a.bar with a B. Now, if this were Java or Ruby or anything else, what you would expect here is for b.bar to be invoked when I call b.foo, because b.foo calls a.bar, calls a.foo, calls a.bar, which is overridden. Alas, that's not what's going to happen. That is the difference between inheritance and composition. Inheritance essentially means A is B. Composition means A is made of B. That is the difference. It's very powerful, though. I want to explain how powerful composition is in comparison to inheritance. So, one of the problems that I have with inheritance, and with people saying that inheritance is very important, or like essentially a mandatory condition for you to have object-oriented language, one of the fundamental problems that I have with this is that single inheritance to me is not a feature. How many features do you know that you can only use once? You only live once is not a feature, okay? It's a limitation. It's a problem. It's an actual problem. You cannot edit a file once. Like, it doesn't make sense. So what you have essentially is a world where, for instance, let's say that I want to describe a vehicle, a truck. A truck could be, on the one hand, a vehicle, and on the other hand, a container of goods. How do you decide which one to inherit? What do? You cannot say A is B and C. You're stuck. This is why I think object or inheritance doesn't work in the real world as well as it should, particularly because of those languages where you only have single inheritance. Now, I started my career with 7 years of C++, and I'm telling you this so that you know I'm smart. Now, I'm telling you this I'm telling you this as a segue to let you know that I've been a developer for 20 years, and after 20 years, I can tell you that all of the imposter syndromes are true, and that I hope that at some point you are also going to feel the same. And then you're going to realize that that it doesn't make sense, all the gatekeeping that we're doing, etc. And you will hire all the juniors. Okay? Okay, good. So back to C++. I started my career with 7 years of C++. It is a very difficult language for various reasons, but one nifty feature that it actually has is multiple inheritance. The thing about multiple inheritance is that when you are able to sort of inherit for multiple types, it actually works a lot like composition. Why? For instance, I have here a type B. Sorry, I have here a type A. It has a method, it has another method. And now I want a type B. I want to create a type B that has a different another method. So what you essentially do in this world of C++, I still have 15 minutes, that's good. What you actually do in this world of C++ is not create type B and then inherit from A and then override, because you don't need to. When you have minimalistic types, you use composition. So in essence, the secret is the good programming with, for instance, C++ or with languages that have multiple inheritance is to use inheritance, but as composition. Instead, I can just create a parent type here, have this one method, put it in both A and B, and have both derive from that parent type. Problem solved, and it is very extensible. So now if I have a C, and I have a D, and I have, whatever, there are, letters of the alphabet, I will get to where I need to go because I'm composing things. If I have a type that only has one method, and it doesn't do exactly what I want it to do, I'm not going to inherit and then override it. It doesn't make sense. So you find yourself with these very minimalistic types that you can work with very, very well. And I know that the creators of Go know this because they worked with C++. So why is it that this idea of single inheritance exists in the first place? Why does this limitation, where does it come from? Well, it comes from something called the diamond problem. Now, the reason I'm putting this in here is not because it's really important to this talk, but it's because I noticed that a lot of people don't necessarily know this very well. So I wanted to help you out. We have type A here. It has a field, let's say an integer. And it has also a foo that returns some string. And then I have B and C, both inherit and override foo. And then I have a D that derives from both. Now, D instantiates C with, I don't know, like with the field. Essentially, you have two copies of A, one with the field being 3 and one being 4. That's what you need to know. So what is the value of field in the context of D? That's the diamond problem. That's essentially it. Now, in languages where you have a common object type that everybody derives from by default, then any sort of arrow that you put here, any inheritance, any multiple inheritance, is actually going to create a cycle and cause this diamond problem. Now, this is another case of engineers not being able to name anything. Agreed? Not a diamond, okay? Not a diamond. Good. We understand each other. So Go is not object-oriented, the argument summary. Go is simple, object-oriented isn't. Go is not object-oriented. Go doesn't have classes, doesn't have inheritance. What we're missing here is doesn't have constructors either. Not object-oriented. And lastly, and this one is really cool. This is the best argument. It is such a great argument. We're going to dive into this argument. Method calls are not really messages. Therefore, Go is not object-oriented. What am I talking about? So this argument comes to us from from what I call the Alan Kay school of object-oriented. Alan Kay is considered to be the person who coined the term object-oriented, and therefore he should know something about it. In addition, he created a language, probably you heard about it, called Smalltalk, where he incorporated his ideas of what object-oriented should be. And voila. So we have, a case study for what object-oriented is. So somebody writes me online. Technically, they aren't method on type T. They are functions where the first argument is type T. We will see what that means. The promotion to them as methods is syntactic sugar. It's why you can call, look at this, v.foo bar. So you have a type, let's say, you instantiate a value and you can call v.foo. You send a message to the type, right? Or you can simply invoke the type .foo and pass in v as the first parameter. Let's see this in action. So we have type A here. It's a new type with an underlying type, the empty struct. You should be saying this with me already, clearly. We added a method foo to it. See, that's wonderful. It returns 1, doesn't do much. And then we're able to call a.foo, and we're also able to invoke the method using the type. So uppercase A, that's the type, .foo, and pass in lowercase a as a parameter. And let's say this in action. Super cool. Most people are not aware, by the way, of this. I don't blame them. And everybody sort of goes, I think it's on the tour of Go, and I think everybody just sort of like passes this part of the tour and forgets it ever existed. So what happens when a pointer receiver is nil? You should know this. Now you should know this. So let's say that I have a type A, which is a new type. Yay, with an underlying type struct, empty struct. Wonderful, good job, good job. And I added a method foo to it with a pointer receiver this time. So the zero value of a pointer receiver is nil. What will happen when I call a.foo? There is a person in the audience who watched an entire meetup go wrong here. 70% answered incorrectly that this will crash. It won't crash because, as we said, this is not really a method call. There is no A is not receiving anything. It's just a function call where A is the first parameter. And since inside here there is no dereferencing to anything, this will just run. Does anybody need me to repeat? We're a small group, so we can, really go into stuff. Okay, good. So receivers can be nil, and the program will not crash. Unbelievable. My Women Who Go co-organizer, Jessica Green, saw this behavior and said, oh my God, so there is no spoon. And I thought it was such tremendously beautiful observation. It's just so wild. Yes, there is no spoon, and you know what? There were also no gophers in the maze earlier, and none of this actually matters this much. These are all philosophical concepts that we use to express ourselves. So where did receivers come from? Well, according to Robert Grismer, co-creator of the language, the inspiration to method receivers came from Oberon 2, which is an object-oriented version of a language called Oberon. Matt. Okay. Understood, right? We got this. Okay. And they're called receivers because they what? It's in the it's in the name. Somebody asked me yesterday if Go was really told me that Go was not designed to be object-oriented. I was like, well, we can argue if it is or isn't, but it has receivers, okay? It has receivers, and they're called receivers because they receive messages. So let's go back to the LNK school of thought here. Can we check at runtime? Okay. So the same person tells me, so in Smalltalk, you don't need to explicitly declare that an object can have a specific message passed to it. The object accepts all messages and decides based on the message whether to handle it or not. So essentially, if it can handle it, like Irina did, right? You could have panicked. Well, you could have, okay. Good, we're in agreement. Awesome. So this is duck typing. What they're describing here is duck typing. But can we check at runtime if an object can receive a message? And so I call this here an interface conversion. The reason that I say this, the technical terms is type assertion. However, there are two types of type assertions. One is to convert something or to check if something implements an interface, and one is to check if whatever it is, your buffer in memory, is of a certain type. So one is implement, one is it actually the thing? Technically, they're very similar. However, they work very differently under the hood. And I do have some recommendation where you can read about this. But let's just, demonstrate. So we have here type A, which is a new type with an underlined type, the empty struct. I added a method foo to its pointer. I return hi from foo. So we see there is no indirection. That's a lot of fun. And then I created an interface I that has the method foo, which is a string. Now, usually when we have interfaces while we're writing the code, we have to explicitly say class A implements I or any equivalent. However, in Go, interfaces, probably the best feature of the language. In Go, interfaces are implicit, so you don't have to say it. And that means that while you're writing code in Go, you don't actually have to know what interfaces your code needs to implement or implements, which is really, really strong. It allows us essentially to pick out whatever random snippets we see on the internet and use them with our own abstractions. It's really, really powerful. Now, because interfaces are implicit, it actually makes sense to ask a thing, well, do you implement this interface or not at runtime? Other languages where interfaces are explicit, the answer would be false. Make sense? Good, okay. So this is the syntax. You don't have to understand it. If you're new to Go, that's fine. But just know that if B implements I, which it is, we're going to invoke foo. And here we go. Hi from foo. It's wonderful. It's really, really cool. And it's very, very different than other languages. So we have something very close to duck typing in Go. Now, this behavior, I spoke to Robert Grismer, again, co-creator of the language, about this. And this behavior was apparently inspired by Smalltalk. And Russ Cox, who is the former lead of the Go team, has a article that explains how this works. Just search for duck typing and Russ Cox, and you will find it. It is a great article. It explains the mechanics. Obviously, you cannot compile a type against all the interfaces in the world because you don't even know that they exist, right? We said it. You have a type, and then somebody else decides, oh, I'm going to use it with this interface. You don't know. So it's really, really interesting how this actually works. So he compared it to duck typing, which, again, we got from Smalltalk. So now we have a surprise witness, because my mom is a lawyer, and I wouldn't be living my legal drama, good life without one. Who here knows a little bit about the background Go? Just a tiny bit. Maybe. Matt, I know you do. You do? Yeah, come on. Yeah. I mean, all you have to do is know how to read. Oh, you don't have to be on stage, but let's, okay. So, what is your name? Sorry? Yannick. Do me a favor, please, and read the paragraph. Yeah.
Go is object-oriented, even though it doesn't have the notion of a class. The type system is more general. Any type, even basic types such as integers and strings, can have methods.
Whoa. Wait, we're not done. Hold it. Okay. Do you remember saying this to Danny Kalev in an interview in 2009 or 10? Yeah?
No.
You don't remember? Well, I choose to trust the internet on this one.
Good.
Okay. All right. So what makes you such an expert that you can make such outrageous claims?
The internet?
Who are you that you can do such a thing?
If you ask like that, it's probably one of the creators.
Ooh. Okay, you have 3 guesses because there's 3.
Rob Pike.
You are Rob Pike, indeed. Thank you very much, Yannick. A round of applause to Rob Pike, to Yannick. To Yannick, Rob Pike. Rob Yannick Pike. All right, so yeah, this is my mic drop moment. Yes, he indeed said this in an interview. It was 2010, obviously. Yeah, we are out of time, so I have to be very, very, very quick because we have a verdict to get to. Yes, Go is still simple. Go doesn't have inheritance, but I mean, to be honest, like without multiple inheritance, I understand why people don't miss it. And method calls behave a lot like messages. So, with that in mind, it's your turn to tell me if I am, sorry, how do I hide? Because, I mean, this was not supposed to be like this. I want to hide. I don't want you to see what each other wrote. This was supposed to be hidden. This is terrible. Oh no, how do I do this? Help, help, please, audience. Where? Where do you see the hide?
Just zoom in on the QR code, maybe.
Oh no, what did I do? Okay, I mean, yeah, thank you. I mean, you know, we're just gonna do it like that, I guess. And it's not going to be a big shock moment. Oh, come on, people. Now you're just breaking my heart. There you go. There you go. Excellent. Okay, we're done here. I'm not playing this game anymore. You were a lovely, lovely jury. Thank you very much for not condemning me to the walk of shame of, I don't know, of programming. And yeah, I guess it's questions time. Yes. Okay.